I welcome you all to CIT Quantum Hackathon workshop series as a part of Quiskit Fall Fest, sponsored by IBM Quantum and Quiskit. I take this privilege to welcome Dr. Jayakumar. He is currently working as assistant professor and serving as IBM Quantum educator as well as IBM Quiskit advocate. He is actively building quantum community across India. He is a IBM certified associate developer, quantum computing using Quiskit. Having 12 plus years of experience in R&D as well as lecturing at university level, he is an active senior IEEE member and participates in building IEEE quantum standards. Congratulations on your achievement, sir. It is quite inspirational journey as well. We are now ready and waiting to hear from you about the quantum games, sir.
Okay, so thanks for a nice introduction. I am Jayakumar. Good day to all. So today we're going to look around quantum games. Yeah, is my screen is visible?
Yes, sir, it is visible.
Fine, thank you. So this session topic is about quantum game theory, which is something very interesting and one of the best way to learn quantum computing through games. Okay, so this is ultimate agenda to learn with a fun way, right? So normally, if you are talking about game, it means it differs to lot of places. The meaning will differ from the lot of context. So we'll look one by one what is a game, how we can define a game, and the motivation of a game will differ from place to place, time to time. For an example, as a noun, it could be an amusement or a pastime, or it could be a contest with rules, the result being determined by skills, strength, or chance. So we have to look carefully. The second point, a contest with rules. So all games, while we are talking about games, when we're going to play a game, so we need to adapt and we need to stick to some rules and regulations. Then only the game will be motivational, inspiring, engaging, right? So if somebody go beyond that rule, they will get punished. Okay, some restriction over there. So we are bounded to rules. When we are playing a games, we are bounded to rules. So if we take any game have some aim to achieve or to win. So one party need to win in order to do all certain kind of tasks. So the result is winning or losing or sometime die, right? So it is determined by skill, strength, or by chance. Okay, what could be the meaning of chance? We can understand skill and strength, and what could be the meaning by chance? If anybody want to answer for this, I can pause.
It's luck by luck if we win.
Oh, yes. So sometimes in some games, the skill and strength is not necessary to play that game. Take an example of Ludo. Okay, take an example of rolling a dice. So in those cases, there is no comparison between skill and strength, just by luck or just by chance. Right? So in second way, if game contains some adjective, eager and willing to do something new or challenging. So this is somewhat different from the first one. Okay, so in the second perspective, it is very adventurous. Okay, if there is any challenge given for us, okay, it will trigger our intuition to do something, to solve something, right, to face it. So this is the very important part in game. right? So we have to explore something, and when we are exploring something, if it is very new, we need to face at first time. We don't know what is the situation before that. We never experienced it. So in that case, the game could be a new task or a challenging task, or you can say it is a adventurous task. Right. The ultimate motive of game to get chance for money. If you take all games at professional level, okay, either either we can win the trophy or we can win the money from that game result. Okay, it is like a payback for the player. Okay, so most probably we know all professional level games across the globe, like tennis, Wimbledon games, or chess, okay, world champion chess game. So they will give a lot of money, tons of money. Okay, right? So there is a famous saying uh, by Jawaharlal Nehru: "Life is like game of cards." Right? The hand that is dealt you is a determinism. The way you play, it's a free will. So we don't know what happened in our life. Sometimes we can plan for something. Sometimes unexpected thing will happen. So we need to face all these things. So whatever happen at our control, we are able to control. Otherwise, if it is beyond our control, we need to face it. So according to it, we need to play with ourselves, right? So by this definition, we are able to guess something about game, what is game, okay, and why we are playing game, what is the motivation for game, and we try to relate with our life. Actually, we can compare our life with game, because game is something exceptional. So there is a multiple states while playing a game. We are not able to expect a linear process. Does nature play games? Definitely yes. So how? We need to explore one by one. At macroscopic level, competition and cooperation between animals at the species level or individual animals. Can anybody look at this statement? Are you able to give example for this? Any example for
For
this statement?
example, peacocks dance
Definitely.
to yeah.
Right. So sometime it is a competition, sometime it is a cooperation. So in the competition sense, survival of fittest. Okay, it need to fight for each other, it need to compete for the resources. Okay, during that time we can consider it is a game. So one party going to win, other party going to lose. Whoever wins, they will grab that resource. Okay, so cooperation, as you said, just like a peacock dance. Okay, something which is doing attracting to the opposite species, right? And survival game. So what we discussed earlier, so we can think game from our life perspective, biological perspective. It is at macroscopic level. If you are looking at microscopic level, discovery that a particular RNA virus may engage in simple two-player game. So whatever we do two-player game, we can try to compare and relate with RNA virus. So it will give lot of information. Okay, how a virus could be formed and structured, what it makes to evolve. So everything we can correlate with game theory. Okay, so another example, protein folding. So protein folding is now turning to a full quantum mechanical treatment at the molecular level with the evidence of games being played. So could anybody tell what could be a protein folding? What is the use of it? Anybody heard about protein folding before this? So protein folding is the process we try to reveal the structure of a protein segment. Okay, in order to completely understand how it is formed, what are the components, okay, what are the ingredients, and how we could adjust and modify it. So we try to reveal the nature secret microscopic level. Okay, so definitely we can do at quantum level. So macroscopic, we are able to see, witness. Microscopic, we are able to see with the, all these medical apparatus. At quantum level, definitely there are so much of games played by the nature. So look at an example. What you can observe from this figure?
Some space scientists are thinking about how Earth is looking from space.
Exactly. But a little deviation here. Here we have to consider like a aliens. So aliens, they are observing our Earth. Okay. So in that perspective, if they try to watch a game of a cricket, okay. So at initial point, aliens don't know about it. It is very new to them, right? So during that time, they have no idea of the rules, okay, because they are new to it. They don't know what is it, why they are playing, what happening at there, right? But if they are observing the outcome of the play for the long time, then they are able to understand it. So this is the point. If something is very new for us, if you are not able to recognize the reason behind it, we need to keep on observe that particular thing. Slowly we are able to reveal that patterns. So this is how we need to approach game theory. So after observing certain things, it came to know what are the rules and regulations. Then they are able to decide what is the status of that game. Even they declare there is a LPW. Okay. So this is the key point. So after watching for a long time, they will pick up the rules for the game. So what happened at here? The rules can be deduced from the observation. So the important parameter at here is to do observation. So how long it should be? It should be longer enough in order to understand the complete structure of your brain. So at initial point, you are not able to identify lot of possibilities. So take an example of cricket. Okay. So what are all the chances or what are all the events you can observe while watching a cricket game? What are all the status? Can you list out?
how how many people are playing, or how many team are wearing the specific clothes, so a collection of, so we can relate it to it.
Okay, fine. So I can simplify. There may be chance of a run out. There may be chance of getting bowled. There may be chance of getting catch. Okay. Sometimes wicket keeper will do stumping. So there are various events. So if you watching cricket for a 5 minutes, you are not able to observe all certain kind of task within the time frame. So this is the key point. So if you want to know that game in a complete manner, if you are very new to it, you need to observe for the longer span of time, so that you can get to know all types of rules. If there is a rain, there may be some laws will be applicable. Okay. If there is a shorter span of time, laws will be applicable, right? So there are a lot of rules, especially if there is a cricket. There is lot of rules when compared to other games. It is somewhat complicated task, right? The longer they observe, the better understanding they have of the rules. So what is the analogy we can get from this? So a scientist observing a system in order to obtain a better understanding, so that a theory may be formulated. Okay. So this is the ultimate theory. If they try to formulate a theory, right, they need to observe for the longer time. It applicable to any system. So in this case, cricket is a system, so it will differ according to your observation, right? So whatever we discussed in previous slide, it is about a macroscopic level. So what about the quantum system, right? So this is our ultimate aim. So the same thing is repeated. A scientist observing a classical system in order to obtain a better understanding, so that the theory may be formulated. So whatever we discussed in last slide, it belongs to a classical system, right? It is observable, easily observable, right? So with the theorem, whatever we assume this theorem and initial conditions, he can predict with this certainty the evolution, the final outcome of the system. So we try to understand whatever we are talking here is all about game. All about game. So synonymously can compare with system, right? So we try to analyze how it is get evolved. How it is evolved. And what is the final outcome, the result of that game, result of that system, right? So actually we can predict. If you are able to understand a system, you can predict. So this is the ultimate purpose of our goal, in order to predict something in future. Okay. So when we compare to quantum level, even with this theorem, whatever we observed, the initial condition, it is possible to end up with a probabilistic outcome. Okay. So try to compare these two statements and tell what is the difference between these two. Are you able to find the difference? I could give you a clue for you. Here there is a certainty, here there is the probabilistic. So what it means? What it means? Are you able to guess?
Means there will be uncertainty.
Exactly. Very good. So this is uncertain in nature. So even though if we going to predict, it is based upon probability. We are not able to say it will happen 100%. So this is the key term for quantum. So in the case of entangled system, even with local probability theory, whatever we are doing, whatever we are studying, cannot able to describe the outcomes. So we need to keep this in our mind. Whenever we are dealing with quantum, the result always is uncertain in nature. So what could be the relevance? So we need to study about the relevance in next slides. The result is quantum games. So if we are able to understand what is a classical game, what is the observable game at macroscopic level, now we try to understand quantum games. So take an example of rolling a dice, which is normal, classical. Tossing a dice may seem probabilistic, but really, if we know the initial conditions and the EOM, we can predict with p equal to 1 what the outcome will be deterministic. So, are you able to identify the result when rolling a dice? Is it possible? Is it possible to predict your output?
Yeah, probability equal to one. That is the probability is 100%. That is yes, the event will going to be happen.
Okay, fine. So, whatever we have to do, we need to know the initial conditions. What is the angle of the dice getting to be rolled? And we need to do this in controlled environment. In controlled environment. Okay, so there is no disturbance, no noise, no air. Okay, if you try to roll the dice, if you know the surface, if you know where it will pitch and what is the force you are applying and how many rolls that dice will get, if you know each and every minute detail, then you are able to predict in exactly. So this is the meaning p equal to 1. If you know all initial conditions, then it is possible. But normally when we are playing in dice in a normal condition without any this restriction, then it is very difficult to understand or predict the output. But if it is in controlled environment and if you know all initial conditions, it is possible to predict your result. This is deterministic. So all classical functions, all classical games are predictable, deterministic. Okay, the result is certain. So outcome of a quantum system can be probabilistic or even cannot be described by local probability theory. So this is the meaning of quantum games. Okay, so there is a famous quote. So everybody know, dog doesn't play dice. A famous saying by Albert Einstein. So because it is very difficult to understand what is the way it will get changed. So there is no rules, nothing you can predict. It is very uncertain in nature, very random in nature. Okay. So what is the purpose of studying quantum games? Why we have to study quantum games? So this question will arise in our mind. So we can go with some kind of points in order to substitute. Different outcomes are obtained for quantum games compared to the classical games, right? By measuring these differences, we are provided with evidence of quantumness of nature, right? So are you able to get anything out of this definition? Are you able to get? So classical game have certain outcomes, but in quantum we have different outcomes. So each time if you play a quantum game, the outputs are so different from the previous one. Okay. So what we have to do, we need to measure this difference between classical and quantum, classical versus quantum, in order to understand what is quantumness, what is the random nature. So synonymously you can say what is a random nature getting played. Okay, so this is the ultimate purpose of why we have to study quantum games. So increased definition in addition to entanglements allows the communication of less information in order to play games, leading to following points: less resources in classical game simulation and better insights into quantum cryptography and computation. Right? So we are able to achieve. So how to reduce our resources? So it will be very helpful in real time. So when there is a huge amount of resources consumed by the game players, we are able to reduce that resources by applying these quantum techniques. And we are able to build a better quantum cryptography and computation if we are able to implement this quantum game theory. So this is the benefit. So this is the purpose we are studying about quantum games. And lot of applications we can apply this concept: quantum finance. We can apply this concept to algorithm design. Okay, a very better, efficient algorithm we can design out of it, and it is very really helpful in quantum chemistry, because quantum chemistry is always about the amalgamation, right? Chemical reaction. We get to know how the quantum level things will happen. Okay, so what is the probability, what is the best way to do it? Okay, it is like a game. So we will have a quick example of a quantum coin toss. First we do classically. Okay, so whatever we do in classical, we have two states: either head or tail we will get at end of that game. So we can say either a flip or a no flip. So if you are able to decide who wants what, if Bob wants head, if the flip happen, then Bob will get win. If allies want to get the tail, if the toss get tail, then allies wins. So the rules is simple. So whatever we do, we have only two states. So one of the state is mapped to each player. So according to the result will get announced. So this is classical 50-50 chance. Once if we are able to measure, we are able to know which one is get selected. So that is why we mentioned it is fair in nature. The result is equal, justified. Take an example in quantum version. quantum seems to be unfair. Why quantum seems to be unfair? We can prepare with these details. So everybody know quantum contains two states, right? Simultaneously. So we can map the z-axis to hits down to the tails. We're going to prepare a quantum state. So sometime if we are preparing quantum state, we are able to fix some position, right? So we are taking this position, we are applying Hadamard to 0, then we will get a positive state, okay? Then whatever you do, flip or no flip, it doesn't make an effort. It doesn't make a serious result effect in your result. So always you will get, if you apply Hadamard to 0, you will get plus. Again, if you are applying Hadamard to plus, you will get 0. So only one state you will get. Is it clear? If it is not clear,
Yes,
I am able to repeat again. So once again, I will do. So in quantum game, quantum coin toss, what we are doing, we are preparing a quantum state. Once you prepare the quantum state, it will never get changed. So, okay. So for an example, if you are applying Hadamard for a 0 state, then ultimately you will get plus state. Okay. So whatever you do, flip or no flip, the result not going to get changed. It only stays in plus state. Again, if you are applying Hadamard to plus state, again you will reach to 0 state. So there is no possibility to get one state. So here, state 1 is completely neglected. Completely neglected. So this is not fair. That is why we are saying, so quantum coin toss is an unfair approach. So what could be the future of a quantum game theory? If you are doing all this stuff, if you try to understand all this stuff, so what is the benefit of it? So it will offer the better insight of quantum algorithm, quantum cryptography, and deeper understanding of phase transition. Okay, and we are able to apply for quantum finance and study of decoherence. I hope some of the concept you already discussed in previous talk series. So I try to give a demo for you. So please check your chat box. I forwarded a link for playing quantum games where you can design your own quantum games. Is my screen visible to you?
yes, sir.
Yes,
Fine.
sir.
Fine. So if you click virtual lab, okay, you can design your own quantum game. So click virtual lab. So this is very basic example of designing quantum systems. So when you're designing, you are able to understand how a photon could be generated, how a photon could be transmitted. Okay, all kind of stuff we can learn through games. While designing, while playing, you get to know. So this is the example of a quantum generator, photon generator. So this is our target. So if we play this game, a photon is get generated from the source and it will impact your resultant. So when it hit, it will keep on count. So how many time that event of chance happen? So you can observe at right hand side. So entanglement you can observe, and what are the experiment outcome, and you can prepare your quantum states. Okay. So this is a simplest example. If I try to play this game, so due to this rock, this photon is not able to reach your resultant. So what you can do? So as per the instruction, you can drag and drop the rock. So you can make a pathway to your resultant. Okay. So in such a way, you can design so many system. You can understand the polarization, all these physical stuff you can learn. Okay. So I hope I gave you a simple glimpse for quantum games. If you want to ask any question, you feel free to ask.
So this game is created by you.
No, no. This game is created by that quantum organization. Uh, Everybody can collaborate to it. It is a open source project. So you can design some level, you can upload to that website also. Please check out the chat box. They will give all kind of description. So if you want to learn any quantum concept, it is easiest way to learn rather than studying theory and doing all this stuff. So whatever we have, superposition, entanglement, okay. So all these kind of stuff we can learn from this quantum game. Any more question?
Means we can do all the things in the IBM Quantum Lab. We can do in this virtual lab by Quantum Light Lab.
Uh, yes, somewhat like that. I will share that screen again.
Yeah, I opened that link and
Yes,
in my another tab, I'm seeing that website.
yes. So you can see all these concepts. You can do polarization, you can modify intensity. Okay, either you can do detections and beams instead of waves. So it will always hit. Actually, we can change the duality of nature. Either we can select waveform or beam form, right? So we can do measurements, we can do entanglement. So all these kind of stuff we can do. And there is no coding needed for this. Okay, just drag and drop.